In this video, we're going to be solving a three-variable system, and this one so happens to come out to no solution. So let's go through what we need to do. So notice that we have three equations, and there are three variables in each equation, x, y, and z. Now you could do this even if there was only two variables in one of the equations as well. It would still work. But in this situation, what we're going to do is we're going to look at all three equations, and we're going to decide which ones we think would be easiest to eliminate a piece of. Now we might say like, well, I'll pick the x's because I can make the x turn into a 5 or a 4 pretty easily. We could say the y's because those two singleton y's can turn into the 5 pretty easy for the y. And then a similar situation for the z's could be made as we made for the x's. So really, it doesn't matter which one you choose here. I'm going to go ahead and I'm going to choose the x's just because I find that sometimes when we have so many decisions to make, that just choosing the first thing might be the easiest. And so in this situation, I'm going to be using equation 1 and equation 2. And so I'm going to try and make equation 1 turn into an opposite reciprocal, excuse me, not an opposite reciprocal, but an opposite, a matching opposite of the 5x. And so in order to do that, I'm going to need to multiply my first equation by a -5. So that's going to have to go to all four pieces, right? So that's going to give me a -5x minus 5y minus 5z equals -10. And because I didn't do anything different to the second equation, I can just write it down. Now, sometimes it's not always that simple, and you'll have to actually multiply something to both equations. And so when that happens, you would multiply it and then write it down, just like we did to that first equation. All right, so now I have both of my equations written down, and I'm going to add them together. And so doing so, my x's are going to cancel out, which is what we were trying to do. And gosh, my y's are canceling out, and my z's are canceling out, and that's giving me a 0 over here. So I have 0 equals, and then -10 and 3 makes a -7. And when I look at this, there's a bit of an issue because 0 does not equal -7. Like this doesn't work. This is not true. Not true. And so at this point right here, we can just stop and we can put down no solution. So we actually came to this conclusion pretty quickly because we just happened to choose the right equations. If we had chosen a different spot, we might not find that it's no solution until the second or the third step. So this is one way to tell, to solve for a no solution, and we're done. Make sure you watch some of the other videos to find for what to do when there's one solution or what to do when there's many solutions.